In this video, we're going to kind of continue off my last one that we started concerning transformations of our parent functions or transformations of functions in general, okay? But specifically rigid transformations, and in this case we're going to talk about translation transformations. So we were discussing vertical and horizontal shift. And so you'll see on the right here, you know, this is still all the same information from my last video, but just a real quick recap here. Given some function h of x, and I'm kind of starting at the top right over here, given some function h of x, if it were equal to some parent function, okay, some really basic function, say plus c on the outside, this would shift its c units vertically up into the air, and if we had minus c, this would shift it vertically, c units vertically down, okay? A little bit different from what we got written here, but given some function, just some function, that appears to be just like a parent function, okay, except for into the parent function maybe we plugged in x plus c or x minus c, okay? That would necessarily cause horizontal shift, and the important thing to remember here is this. If I had f of x plus c, okay, inside those parentheses, it actually shifts it to the left, okay? And if we had x minus c here, it actually shifts it to the right, okay? So just, I think the best thing to do here is probably kind of play around with this one for a sec. So how about I give a function here, we call it h of x, just to go with the theme. And we say h of x in this case, we're going to call it x cubed plus 3, okay? So the first thing I want to do is look at this and say, okay, which one of the parent functions, there are about 8 of them that we memorize. We have a constant function, linear, quadratic, or the squaring function. We got the root function. We've got the greatest integer function. We have the cubic function. And all these parent functions. But this one in particular appears to look like the cubic function, which was f of x equals x cubed. So my number one recommendation to students is this. Once you identify the parent function, what I want you to do is necessarily write it over here and write it as f of x. And you know what, even better, you're probably going to be asked to graph this other function right there. And so once you get your parent function identified, let's go ahead and graph the parent function. So the cubic function started at 0, 0, okay, 0, 0, went up 1, right 1, okay, and went left 1, down 1, left 1, and it looked like this, okay. So what I want you to know already is this. Already, since we've identified the parent function f of x, I just want you to realize that h of x is just some sort of alternate form of the original in which it's slightly different, okay? So now that I know that f of x is x cubed as our parent function, I want to know, how does adding 3 or h of x being x cubed plus 3 necessarily affect it, okay? So you'll notice first and foremost, I hope, that this x cubed right here is the same thing as f of x. So in other words, we could rewrite h of x as f of x, since that's the same thing as x cubed anyways. We'll substitute that in, plus 3. And then kind of refer to our chart over here on the right. You'll notice right up here at the top, this is the very first instance of what we were talking about previously. But this c value actually is going to cause vertical shift. Okay, so this plus 3 tacked onto the end of our x cubed here is going to cause vertical shift. And in this case, vertical shift doesn't lie. If it says plus 3, it's going to be shifting 3 up into the air. Okay, so we'll go ahead and take our original parent function and necessarily take all the points and shift them up 3. So the beginning point here wouldn't have started at 0, 0, would have started at 0, 3, gone up 1 over 1 from here, and then down 1, back 1 from there, and really proceeded kind of in the same fashion. But what you'll notice here is all we've done is taken the original parent function here in blue, and we've altered it, or we've transformed it into this new function h of x, just by kind of looking at how h of x is an alteration of the original parent function. It was really the original parent function there, x cubed, and tacked on 3 to the end. Okay, so the question has to be this. What if we define some new function? I don't know, we'll call this g of x. G of x. And g of x looks like this. We say, okay, so g of x is x plus 1 cubed minus 2. Okay? Already again, we can see here, because of this cubed on this x kind of quantity here, we know this is going to be an alteration of this original blue graph right over here. Okay, it's going to be an alteration of this original f of x. The question is, how is it going to be translated? Okay, so first things first, I kind of want to rewrite this function g of x in terms of the original parent function. So here's what we'll do. We'll say, okay, so g of x is equal to, now you'll notice here that this almost could be like an x cubed, but it's an x plus 1 cubed, which would necessarily imply that this is kind of like our original parent function f of x, but instead of having just x cubed, we have x of, or f of x plus 1 plugged in. So f of x plus 1 would really be like this first term here, okay? So we say, all right, this would be f of x plus 1, and then off to the side here we're subtracting 2. So really what I'm doing in this example is kind of combining two of our translations here. This minus 2 out here is going to cause a vertical shift of down 2, but looking at this parenthetical quantity, you notice we have a plus 1, okay? So let's kind of point our eyes back over here at this h of x in here. We said if h of x is kind of like the parent function in which we've added, or plugged in an x plus c on the inside of the parentheses, then this is actually going to shift it horizontally. In this instance, opposite of what this operator in here would indicate. So since this is a plus 1 over here, we're saying it's going to shift 1 horizontally but 1 to the left. So really what I'd like to say is this graph g of x is going to be just like our blue graph f of x here, except for it's going to shift left 1, horizontal shift of left 1, and then it's going to go down 2. So I always find, you start with the original point you drew on your parent function. Let's shift that one and then work from there. But we say, okay, so left 1 is going to go left 1, and down 2, 1, 2. So this will be located here. And then it'll proceed up 1 over 1 to the right, like a cubic function does, and then down 1, left 1. Here, we can shift this in. And if we analyze this now, it's kind of hard to see with all this going on, but we say the original graph did no more than shift left 1 and down 2. Okay, so the whole point of this set of exercises is to kind of analyze translation. So why don't we work one more here? How about we go with a different function besides the cubic function? We'll go with we'll call it t of x, and t of x will be defined as the square root of x minus 2 plus 2. Okay. So in terms of parent function, let's go ahead and identify that. Parent function in this instance is going to be an original f of x, okay, f of x, and f of x would be the root function, okay. So the root function, go ahead and draw this in here. I'll go back to white real quick. The root function looked like, we'll go ahead and go with blue. It started at 0, 0, went up 1 and right 1, passed through this point 1, 1. It was like a sideways parabola, half a sideways parabola. So we could say this is our parent function. So we're really trying to analyze, so how would t of x here, how would t of x be different than the original parent function? So instead of square root of x, you notice we've also buried a minus 2 in here with our x, okay? I'm going to put that in parentheses, and then a plus 2 here on the outside. So before I go ahead and rewrite this in terms of f of x being transformed, I want to point out this. This negative 2 hanging out with our x here is going to be our horizontal shift, and our plus 2 hanging out here is going to be vertical shift. So already what I want you to realize is this horizontal shift, this in here with x is going to lie. This is actually going to shift 2 to the right, okay? And this plus 2 on the outside does not lie. It's going to shift 2 up. So if we took our original point right here and we shifted it up 2, 1, 2, and then 2 to the right, say, okay, so this is like our original parent function shifted 2 right, 2 up, or 2 up, 2 right, and then proceeds to go up 1 and over 1 to the right. You see that we have the original function. It's gone up 2 over 2. So now let's rethink this one in terms of, say, f of x. So let's rewrite t of x in terms of f of x. We say t of x is some other form of f of x. But here's what it would necessarily look like. If f of x is the square root of x, then to get the square root of x minus 2, we'd have to say that would be f of x minus 2, or the function when we plug in x minus 2 for that x right there. That would make it look like this. Okay? And then we also have this plus 2 on the right. So kind of going over here and looking at our indicators, we say this would just be horizontal and vertical translation. So we need to be aware of these.